Alright, welcome back to Exam Help and Care Academy. We promise you to always give you academic excellence on each topic on sciences, maths, physics, chemistry, and possibly further maths. So now we are on physics today. So we'll be dealing with tensile stress and strain. Tensile stress and strain. So tensile stress and strain is a subtopic under elastic properties of solid. Elastic properties of solid. It's a topic you usually do in SS1. That's your senior class in SS1. Then it appears in WAEC and external exams like JAMB and NECO and other post-UTME courses. Now let's go immediately to what we have on the board. Now tensile stress and strain. Now it says, given a wire of length L and cross-sectional area A. Given a wire of length L. So the wire of length is L and cross-sectional area is what? A. So if the wire is extended through E. If the wire is extended through E. So that E stands for extension of the wire. Say by a force F. Then tensile stress is defined as the ratio of the force to the what? Area. So we can now define tensile stress as the ratio of force to the what? Area. So this is the formula. Tensile stress equals to force over area, or force per unit area. So the SI unit for tensile stress is Newton meter raised to power minus 2. Or you say Newton per meter squared. Newton per meter squared. Now, followed down, they say that tensile strain, because it is two, stress and what? Strain. Now, tensile strain is defined as the ratio of the extension to the original length. I repeat again that tensile strain is defined as the ratio of the extension to the original what? Length. Now, the tensile strain is E. Remember I said E stands for the extension, extended through. So it's the extension, and you can see it's extension to the original what? Length. So this now, it has no what? No SI unit. It has no what? SI unit. Now, this will now lead us to what we know as Hooke's law. Now, Hooke's law can also be stated as follows, that stress is proportional to what? Strain. Stress is proportional to what? Strain. If the stress is directly proportional to strain, provided elastic limit is not what? Exceeded. Provided the elastic limit is not what? Exceeded. Now, if you look at the other side, you'll see we started the calculation from here. Stress is directly proportional to strain. Formula for stress S over A. Strain is E over L. So if you do your calculations properly, let's say F over A is equals to constant, because you always have a constant to show the variation of the proportionality. You get that? Yeah. So when you do mathematics variation, there must be something to show the variation. Now, this constant of proportionality is called Young's modulus. It's called what? Young's modulus of elasticity. So the Young's modulus of elasticity, Y, with a capital letter Y. So it is therefore the ratio of stress to what? Strain. The ratio of stress to what? Strain. So if you look at this sincerely, you look at that, therefore, because of our students, they think that it's a scientific notation. Please, that's therefore. So F over A is equals to the Young's modulus E this. So now you cross multiply and everything. We don't want to disturb you with that, but if you know that here, if you have something here now as your coefficient, let's say this is a coefficient of this, so and you want to make Y the subject of the formula, you divide both sides by what? EL, right? Yeah. So F over L divided by what? E over L. So its SI unit is Newton meter raised to power minus 2. Newton meter raised to power minus what? 2. So now we'll be solving one or two questions now immediately. So get ready with your calculator and your pen and your notebook. Alright, let's continue. So, tensile stress and strain example 1. Now, the question says a wire of length. A wire of what? Length. 2.0 meter and radius 1.0 millimeter, millimeter, is stressed by 25.0 millimeter on application of a force of 10 raised to power 3 Newton. Now, it says calculate the Young's modulus of the what? Y. Calculate the Young modulus of the what? The Y. Now, this is a straight question, but you know, I do tell students, you have to read the question, understand it before trying to solve the question. So we take our parameters one after the other, and if you know, the question went directly to say calculate the Young modulus of the Y, and in Young modulus we have the Young modulus, formula for Young modulus is equals to the force per unit area all over E, that's the extension over L, E over L. Now, let's look at all the things that are there. First of all, we have a wire of length 2.00 meter. So length is 2.00 meter. You can as well write 2 meter because the 0, we have no use to it. And radius, the radius is what? 1.0 millimeter. 1.0 millimeter. Now, but you ask yourself, radius, was radius in our formula? Radius was not entirely in our formula. So what we're going to do is that the radius, from the definition which we have first, the radius will lead us to what is called the cross-sectional area. Cross-sectional area. So we'll take it in place of cross-sectional area. So we'll apply some mathematics calculation on that. So 1.00 millimeter. So now, you know, since we are making use of standard units, that is fundamental quantities and derived quantities, so we'll base the unit. This is meter, so this has to be in what? Meter. Now, before you convert to this to meter and the area itself, we know that to convert this to meter, we said that 1000 millimeter will give us 1 meter. I repeat again, 1000 millimeter gives us what? 1 meter. So we are going to convert 1 millimeter to what? Meter. As meter which we are looking for. Unknown. We're looking for it. So what you do is just cross multiply, right? Yeah. Say 1 times 1 over 1000. So 1 times 1 is 1, then over 1000. And if you do this with your calculator, I believe, even without calculator, if you're a good mathematician, there's a way we do it. We'll say 1, 2, 3. So it becomes 0. You have 3 zeros. 1, 2, 3. So it will be 0, 0, 1, right? Yeah. 0.001 meter. Do you get that? Yeah. So our new radius is 0.001 meter. Do you get that? Yeah. Now the next thing to do is the cross-sectional area. So area here, cross-sectional area, you convert it. So it will not be, the normal formula for area is pi r what squared. Are you getting that?
Yeah.
So now, basically, it's more preferable to use 22/7 first of all, and times our r is 0.001 meter. 0.00. So put this in bracket, parenthesis, and raise to power what? 2. So what we'll do is we'll square this, then we continue with this. So you'll help me with your calculator as we do that. So 22/7 times 0.001 squared. So let's see what you got.
For 22 divided by 7 is 3.142.
Okay. I was thinking you give us this first, but you want 3.142. Okay, let's use 3.142. That's normal. It's 3.142. We all know. Then times, give us the square of this, 0.001 squared.
Times 0.00001
squared. That's 0.001 times 0.001.
Yeah.
What did you get?
0.95041.
1, 2, 3, 4, 5, right?
Yeah.
1. Good. Alright. So when you square this is what you get in this, right?
Yeah.
Okay. Now you can do this one as standard form. If you do this one in standard form, what you'll be getting is 1 times 10 raised to power 1, 2, 3, 4, 5, 6. 1 times 10 raised to power minus what? 6, right?
Yeah.
Well, let's see if we times it with this. 3.142 times 0.001. What will you get for cross-sectional area? Cross-sectional area. I believe if you times it, this is what I'm getting. I'm getting 0.00000. That should be
3.142.
1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. Then 3, 1, 4, 2. Right?
Yeah.
So converting it to standard form will now be 3.142, right?
Yeah.
Times 10 raised to power 1, 2, 3, 4, 5, 6, right?
Yeah.
Times 10 raised to power minus 6. Good. So that's for that. Now we're going to continue. We have gotten length. We have gotten A, which is a cross-sectional what? Area. Now it said is stretched by 25.0 millimeter. Now, since it is stressed by 25.0 millimeter, what does that stress means? The stress means the extension. The stress means the what? Extension. So extension, bracket stretched, which is represented with small letter E, is 25.00 millimeter. So just convert this one to millimeter. You say 25 divided by what? 1,000. So that should be giving us 0.1, 2, 3.
0.025.
0.025. Is that it?
Yeah.
Alright, let me confirm. Yes, 0.025 meter. So we're getting it. We've gotten the extension. So we're going to clean the Young modulus formula here and see what we can get. Now, remember we've gotten several parameters: length 2.00 meter, or 2 meters. Radius, cross-sectional area converted. At the end, what we got was 3.142 times 10 raised to power minus what? 6. Now, extension was given directly, but you convert from millimeter to what? Meter. Now, the last thing we need is the what? The force. Is the what? Force. Because it said on application of a force, 10 raised to power 3 Newton. So the force F is equals to 10 raised to power 3 what? Newton. So now with this, I believe we can now solve effectively. We can now substitute everything which we have into the formula. So what is our F? Our F is 10 raised to power what? 3 over, you can do it like this, over A. What is our A? Our A is 3.142 times 10 raised to power minus what? 6. And finally, all over, what is E? 0.025. 0.025. All over the L, which is the length, is 2.00 meter. So which is the same thing as 2 meters. So divided by 2. Alright. So this is a bigger one. We'll solve numerator, denominator separate. So let's see. This is equals to 10 raised to power 3 should be giving us 1000, right?
Yeah.
Over 3.142 times 10 raised to power minus 6. Then do for us 0.025 divided by 2. Let's see what we have.
Okay, 0.0125.
0.0125. 0.0125. Wow. Okay. If you don't want to do this, you can say times, then you take the denominator up 2 and bring 0.025 down. But let's just do this way. So now, y, which is the Young modulus, is equals to 1000 all over 3.142 times 10 raised to power what? Minus 6. Okay, if we say this is over 1, right?
Yeah.
Now let's say 1000 over 3.142. Are you with me?
Yeah.
Then I say times. What would I do now? Take one up, right?
Yeah.
And bring 0.00125. In solving any question, you have to be tactical. You have to use your mind, because you can see that this is in decimals, right?
Yeah.
And this is a whole number. So it will be better you bring this one down so that you can be able to compete with these two. That's times 10 raised to power what? Minus 6. And definitely I can still change this one to what? Standard form, which will be more easier. So WAEC students and JAMB students, take note of this. So this times this is 1000. That's 1000 times 1 is 1. So the next thing is 3.142. Okay, 3.142 times 10 raised to power minus 6 times, convert this one to standard form, which will now be 1.25 times 10 raised to power what? Minus 2. Right?
Yeah.
Good. So if you know this very well, the next thing we will do is we'll times this and add the what? The powers of what? 10. Right?
Yeah.
So I'm going to clean here and get ready for this. So we'll continue from here. Y equals to that. So Young modulus is equal to 1000 all over 3.142 times 1.25 times 10 raised to power minus 6 plus bracket minus what? 2. If you're a professional, you can just say plus times minus is what? Minus. So just for those who are learning sake. So 1000 all over, let's go 3.142 times 1.25. Please make sure you clear your calculator very well before doing that. AC on 3.142 times 1.25. Then give us in SD. What do you have on that?
3.9275.
Let's go again.
3.927.
3.9275. 90 or 92?
92.
Okay, but we'll call it 9275. Good. Now, times 10 raised to power minus 6 what?
That is minus 8.
Minus 6 minus 2. Okay. Y is equals to 1000 all over 3.9275
times 10 raised to power minus 8.
times 10 raised to power what?
Minus 8.
Minus 8. Good. Now, your modulus is equals to 1000. What do you think will happen?
The numerator will go up.
Go up, and
the minus sign changes to plus.
good, very good. Times 3.9275 times 10 raised to power what?
Minus 8.
No, minus 8 plus positive
8.
That should be positive 8.
Yes, okay. Should that one also go up with it?
Which one?
The 3.92.
Yeah, let's see.
Okay.
Are you good?
Yeah.
Alright. Now, watch what I'm going to do now. You can times immediately, or you can decide to put this one in standard form. Okay. Let's watch. Y is equals to 1000 times 3.9275. What will it give us?
That is giving us 3,000.
Okay.
927.5.
3,000.
927.5.
Okay, let's do it this way. Let's say, okay, before you do that, do 1000 divided by 3.9275. Let's see.
That's giving us 254.61.
254.
Yes, 0.614.
254. 54.
Yeah, 0.614.
0.614. Okay. So I think we were correct. What we're going to do is take 10 upwards and leave this one downwards, so that the other one will divide itself. Alright. So we're going to clean this and take this way. So 1000 all over 3.9275 times 10 raised to power
8.
Positive 8. So 1000 divided by 3.9275.
254.61.
254.
54.614.
Times 10 raised to power 8. But that's not our final answer. Let's see if we can make it to the nearest decimal, 1 decimal, or whatever. So now, let's say this is 254.614, right?
Yeah.
We change this one to its standard form of itself. Let's say this is 254.6, right?
Yeah.
Then remember that we're going to take this one as a whole number. Okay, let's say 255.
Okay.
we have approximated to the nearest whole number, right?
Yeah.
Then times 10 raised to power what? 8. So this should now be 2.55 times 10 raised to power what? 2 times 10 raised to power what? 8. So y, the Young modulus, is 2.6, right?
Yeah.
Times 10 raised to power 10. Positive 10. Then the SI unit is Newton meter raised to power minus 2. So this is the correct answer. 2.6 times 10 raised to power what? 10 Newton
meter minus 2.
Newton meter raised to power minus 2. Newton per meter squared. So thank you for watching. So do not forget the steps that we used. The several steps are very necessary, like we did from here, 10 raised to power 3 all over this. You do the top before the bottom. Like I said, you can also decide to do times. Yeah, you can say times 2 over 0.215. You'll still get your process, but just be careful. Then, for those who are learning this, we are all learning step by step. So when you get to this part, 1000 over 3.9275 times 10 raised to power minus 8. Once you do is, do not take this up immediately. No, take only the powers of 10 upwards. So when you take the powers of 10 upwards, what you get is 10 raised to power positive what? 8, and no longer minus 8. Maybe you have 10 raised to power 8 down. If it goes up, it will now be what? Minus 8. Good. So you now do this with division sign, and you get this, and you continue, and you have your final answer. Alright, thank you for watching.